NASA has made a groundbreaking discovery as they finally opened the space capsule containing the largest asteroid sample ever collected by a space mission. This exceptional sample hails from Bennu, a potentially hazardous asteroid that holds a unique time capsule from the early solar system. On September 26, 2023, scientists at NASA's Johnson Space Center in Houston unveiled the treasure inside the sample return canister from the OSIRIS-REx mission. This mission had returned to Earth just 2 days earlier with the long-awaited sample from the asteroid. As the lid was lifted, scientists were greeted with a surprising sight, a layer of black dust and debris on the avionics deck of the canister. Additionally, the sample weighed 100 grams more than initially collected from Bennu. This unexpected finding left everyone puzzled, as the sample had been securely stored in a sealed container throughout the journey. The questions that arise are manifold. How did the black dust appear on the avionics deck? What is the source of this unexpected material? Most importantly, what do scientists anticipate to uncover in their detailed analysis of the largest asteroid sample ever returned to Earth? When the OSIRIS-REx mission was launched on September 8, 2016, it had 3 primary objectives. The first was sample collection, aiming to obtain pristine samples from the asteroid's surface for scientific study. The second objective was asteroid characterization, involving mapping and understanding Bennu's geology and composition. The third was Earth's impact hazard assessment, considering the potential threat posed by Bennu. Bennu's flyby of Earth on September 25, 2135, creates complexity in predicting its trajectory due to non-gravitational forces, such as the Yarkovsky effect. This effect is challenging to model but can significantly influence the asteroid's path, making it crucial to determine Bennu's future course. Scientists have to consider various possible trajectories due to the Yarkovsky effect, some leading to gravitational keyholes, which could alter Bennu's path toward Earth. The journey to Bennu was a 2-year, 4-month voyage. On December 3, 2018, OSIRIS-REx reached its destination after traveling around 1.4 billion miles, 2.2 billion kilometers, entering orbit around the asteroid. The most thrilling phase of the mission was the sample collection event on October 20, 2020, executed using the touch-and-go sample acquisition mechanism, TAGSUM. During this brief contact, OSIRIS-REx collected a remarkable 300 grams of the sample, exceeding NASA's expectations. However, an issue arose during the sample encapsulation due to a jammed flap caused by larger rocks, preventing further measurements. Despite this, OSIRIS-REx departed Bennu on May 10, 2021, and began its journey back to Earth. On September 24, 2023, the spacecraft reached Earth's vicinity and released the capsule containing the asteroid sample, which safely landed in Utah. Upon opening the capsule, scientists were surprised to find dark powder and sand-sized particles on the avionics deck. NASA believes that OSIRIS-REx's brief contact with Bennu generated a shockwave, expelling materials into space, some of which attached to the spacecraft. A portion of this material entered the sample canister during the collection process, creating a combined mass of approximately 400 grams. While the presence of dust and debris on the avionics deck poses a unique challenge, scientists aim to handle and clean it carefully using specialized tools and techniques without compromising the electronics or the sample. They must meticulously document and catalog every fragment, as they are essential components of the sample inventory. Asteroid missions like OSIRIS-REx are crucial because asteroids serve as time capsules, preserving the early solar system's composition and history. They offer insights into the building blocks of life, and the discovery of organic molecules on asteroids like Ryugu underscores their significance. These missions help us understand the origin of life's ingredients and the potential role of asteroids in seeding life on Earth. The next phase of the mission, OSIRIS-APEX, will focus on studying asteroid Apophis, which could pose a future impact threat. The knowledge gained from OSIRIS-APEX will enhance our ability to protect Earth from asteroid impacts. This historic mission showcases the importance of exploring and studying asteroids, unlocking the secrets of our solar system's past and the potential implications for our future.